Hey everybody, and welcome to Memory. This is the capstone experience for memory in the psychology department at Westfield State University. As you probably know already, my name is Alex Daniel, and I am very happy to work with you this semester. As I mentioned in my introduction video, memory is, I guess, my expertise. If I had to pick any area of psychology that I feel like I am an quote-unquote expert in, it would be in memory. I am so excited to do this class with you, to go on this journey, to take this adventure, because I love talking about this stuff. I find this stuff endlessly entertaining and interesting. I have been researching memory, I guess it technically started when I was an undergrad, and I had a research methods project which was about false memory, which is something that we are going to be talking about later this semester. But I feel like my journey kind of started there, and I'm going to say that was, oh boy, I'm going to give away my age with this. That would have been in like 2008. So that's how long I have been studying memory. So let's get into it. What I want to do in this unit, because this is our first unit, is just basically get you thinking about what is and what is not memory. As you're going to see this semester, memory covers a lot of ground. A lot of things can be considered memory. As you can see from this flow chart, which we are going to be looking at a lot this semester, I want us to be thinking, as we kind of look at some of the examples I have prepared for you, thinking about, well, what exactly would a definition of memory look like? How inclusive does it have to be? Does it have to include things like remembering how something smells, or remembering the name and birthday of your neighbor, or the way a specific soup tastes, or a childhood memory? There's so many different facets that could cover it. And you can kind of see this reflected in this flow chart. Again, we're going to be coming all semester back to this, because when we talk about memory, there are ways that you can split it up. So we can talk about explicit memory, which is memory for a conscious recall, for things you can put into words. And then we have implicit memory, which is more indirect. So it's memories that you can't verbalize, that you can't consciously articulate. And so I'm not gonna spoil the rest of the class. I'm just gonna leave it at that. But you can see that even then, we can still break it down further into different kind of subsystems of memory. So this section, I want to kind of look at some examples and get you thinking about where that line ends for what memory is. So whenever I put this up as a question in a classroom, usually when I'm doing this in person instead of online, in person is more of a discussion format where we come in and it's really cheesy. We turn all the desks towards one another and we kind of like look at each other and we talk about the different research articles that we're going to be exploring this semester. And this is the question that I ask at the very, very beginning. What is memory? And I get a lot of different answers for that. And that's okay, because as you just saw, there's not going to be one specific definition that works for every single thing, in my opinion. If you can get a definition that can include all of this, it's going to be really, really vague. So as an example, I would say, personally, if I should have prepared for this, but if I were to answer what is memory, I'd probably say something like, it is the ability to temporarily store and manipulate and retrieve information when it is absent from the environment. And what that means, and again, that's a really vague kind of definition. You don't need to dedicate that to memory by any means. But basically what that means is that we are taking some kind of stimulus that we have exposure to. Maybe we heard about it, maybe we see it, maybe we felt it. And whenever it is gone, when that stimulus is gone from the environment, that we have the ability to recall something about that stimulus. And maybe that is, you can tell me about it, or maybe it's, if it was in a lineup, that you could pick out which stimulus it was. There's a lot of different ways that we could ask that question, but you can kind of see, what I mean, that, that's really, really vague, and it's really abstract, and I feel like it's so abstract that almost all psychology can kind of be memory if you think about it that way. But we're not going to think about it like that just yet. We're gonna move on for now, because what I want us to be thinking about is explanations by different levels. And what I mean by that is when we're talking about memory, we can talk about it in a really technical, kind of jargon-heavy way that would befit a textbook or a scholarly article. The definition that I just gave you was more like something that you would expect in a textbook or a scholarly article, right? If I were to describe memory for a 5-year-old, I would use a different set of explanations. I would use a different kind of explanation for how that system works. I would probably say like, do you remember how something feels? Well, your ability to do that is your memory. I'm trying to think of like, can you remember? But I can't use remember and talk about memory, right? That's a circular logic. But if I could say like, what could you tell me about last Christmas? What did you get for last Christmas? And then the 5-year-old, I'm going to say it's my niece Caroline. She says, oh, I remember getting X, Y, and Z. And like, you can remember that because of your memory. Your ability to do that is your memory. It's like a superpower. Okay, so let's look at a few different examples and discuss whether or not this is memory. So here is the first example.
A conditioned taste aversion can occur when an organism ingests something that makes them ill. For example, Susan here has a conditioned taste aversion to mushu pork. So Susan, how does that make you feel?
Oh gosh. I feel like I might want to vomit, and I'm salivating, and I don't like it at all.
I'm sorry, I'll put it down. Susan's nausea and sickness is paired with the sight, the smell, and the taste of the food. So from an evolutionary perspective, this makes sense. We should try to avoid things in the future that have made us ill. So sorry, Susan, that was just a little payback for Tickles the Snake.
I forgive you, Lauren.
Thanks.
Here we can see that conditioned taste aversion happens after only one trial. That's different from classical conditioning where we have repeated presentations. For example, I got sick on mushu pork over 10 years ago, and as you can see today, I still can't stomach it. So let's move away from the mushu pork example. I'd like to finish this lesson on classical conditioning by talking about a study that classically conditioned a sexual response to women's black boots.
A conditioned taste aversion.
All right, and I know that that whatever experiment she was about to talk about sounds really interesting, right? But the point here is that this is an example of, sorry, you can hear my dog scratching. Sorry about that. I don't know why he's itchy right now. He just wants some attention. But here, this is classical conditioning. What is that doing in a memory class, right? That's something that you talk about in Psych 101. It's something you talk about in your behaviorism or your learning class. But I think that we can make a really good argument that this is an example of memory, right? Because what's happening here is that she was exposed to a stimulus, mushu pork in this case. She was sick. She associated that with the mushu pork. And then now, whenever the mushu pork is reintroduced, she remembers that stimulus. She remembers getting sick, and she has that kind of connected, that paired association with it. So is that an example of memory? I don't know. What do you think? I don't know. That's, I already told you kind of how I feel about it, right? I think it does qualify as a memory. And if you're skeptical about it, that's okay. But I want you to keep an open mind because we're going to be tackling a couple of subjects this semester that get a little bit closer to taste aversion and whether or not taste aversion is an example of long-term memory. All right, let's look at another example here with some kids talking about their dreams.
Find the perfect
Oh,
mattress
sorry,
for
we
your
got a
best
Labor Day
sleep during the
mattress
Labor
sale.
Day
How
mattress sale at
exciting
Rainbow
is
Ward
that?
Flanagan.
Does everybody dream? I had a dream where I was flying, I hit the wall. A lot of times I have scary dreams, and sometimes I have dreams about wrestlers. I sleep with a teddy bear or a rabbit.
Uh-oh. Oh, that's fun that it's like lagging or whatever. It looks like it's still playing, but...
It's special because I even had it when I was a baby. It was ripped right here so big, and here and here and here. But I don't take it everywhere, not in the store. I take him to the bathroom, but not in the bathtub. He'll get wet so much, and then he'll rip. Blanky is his name. I actually turn on all of the lights because I'm scared of the dark. Well, you know what?
Okay, well, so you get that now they're talking about their nighttime routines. But I wanted to kind of capture a little bit of them talking about their dreams, because that is an example of, like, all right, if you're able to talk about your dreams, that's an example of a stimulus that was never really presented in the environment, right? That was totally in your head, right? So if you can remember a dream, then you're remembering an internal event, right? That's weird, right? Like, I wouldn't have thought about that as an example of a memory, but I feel like that will qualify as a memory, right? All right, let's take another look. All right, so here's a strange example. What you're going to be looking at here is a slime mold, and there is some nutrients right here, and then some nutrients right here on the other side of the maze. And let's watch what happens over time. You can see the slime mold slowly proliferating. Let's see what it does. All right, so now we have the nutrients that are packed right there, and over time, this is time-lapse footage, right? So this is sped up footage over several hours. But we're going to see now, it looks like the slime mold has reached this part of the nutrient. And let's see what happens to the rest of this maze. Now, the reason why I'm showing this example is because usually whenever we talk about maze learning, that is an example of memory formation. Whenever you may have seen like the stereotypical like rats solving a maze, right? And that being used as an example of like rats really smart, they can solve mazes and stuff like that. And I think most people will say like that's an example of problem solving, it's an example of memory. But if we're looking right here, for this example, it looks like the slime mold is, maybe it's not running, right? It's not picking up and moving, but you can kind of clearly see that some of these lanes that do not reach the exit, like these right here, all right here in the middle, these are not, not doing so hot, whereas between the lanes that are connecting this nutrient piece and this nutrient piece are actually becoming pretty robust. They're getting stronger and stronger and stronger, whereas over here we're not really making a whole lot of progress. And let's just see what happens. I'm going to fast forward a little bit. You can see it get even stronger, that pattern sticking out even more. And there we go. That you can see that the slime mold is most dense, most concentrated, starting here, moving all the way right there. Basically the quickest path to the exit. Now, is that an example of memory formation? I don't know. I really don't know. Some people say yes, some people say no. I'd be curious to hear what you think. All right, so here is another, maybe a more classical example. Let's take a look at this whiz kid solving a Rubik's Cube.
Build a website
we got an
love
ad, folks. We got
with
an ad.
Wix.
I should turn on my ad blocker.
For your words,
All right. All right, so you saw he was looking at the Rubik's Cube, and then over the course of a few seconds, I love all the reactions. Here, watch this guy over here. We've all been there, right? We've all been there. But so in this case, does this require memory? I think that we would all say yes, right? Because what he's doing is he's looking at this. He's looking at that cube, and if you've never played with the Rubik's Cube before, you've probably seen it on TV, right? That basically you kind of twist and turn this cube. Actually, I have one right here, folks. But you twist it and you turn it so that you get all of the colors on each corresponding side, so that it is all red and all yellow, all blue on one side. But this is not this is a little bit different again, right? Because what he's doing is he's looking at this cube and now he's making preparations. He's thinking to himself, what do I need to do? What, twists and turns do I need to make in order to get to that side? All right, here is another example. This one, if you thought that last one was amazing, check out the 7-year-old.
Build a website.
Sorry, we got another ad. I think this is going to happen for all of them. I've become one of those professors that has ads. I used to be one of those hip, cool professors that found ways to prevent ads from showing up, but not anymore. All right, let's check out this kid. He's examining the cube just like we saw from the previous guy. He's checking it out and seeing how long he takes for him to study it, right? All right, and you can see him thinking. He's not even looking at it, right? He's thinking to himself. What's he doing? He's thinking about what steps he needs to take in order to solve that Rubik's Cube. Now, why am I showing you this, right? Because you just saw the last one. So what's different about this one? This little kid, he's got the juice. Watch him. Here we go. He's got to pick his nose. All right, kid, come on. We ain't got all semester. All right, fast forwarding a little bit. All right, here we go. Any moment now. All right. All right, what's he doing? He's pulling the blindfold down. They're making sure that he can't see it, and he's doing it completely from memory now. So this is all in his mind's eye. This is all him when he closes his eyes, what he's seeing. He needs to be able to see that Rubik's Cube as he's manipulating it in his mind's eye. Earlier, when I was explaining that memory could require manipulation of a stimulus, this is exactly what I mean. That thinking about how things might be different whenever you rotate those corners, for example. Look at that. Here he goes. Here he goes. It's getting close. Boom. And he's like not even that excited. The cool thing about that, I think, is that he knew. He knew when it was done. Right? Like, he knew when it was done, he dropped it, and then took off the blindfold. That is amazing. All right. So I think we would agree that is memory. What about this?
Babies
We're looking at some
are born with
newborns
a set
now.
of reflexes critical for survival in the outside world. Some of these reflexes are so obvious you might not think to look for them, such as the breathing reflex or the eye blink reflex. Rooting is one of the most critical reflexes. By touching 4-week-old Lily's cheek, she'll turn her head and open her mouth in preparation for nursing. Once the baby is in contact with a breast, a bottle, or even a finger, the sucking reflex takes over. Involuntary at first, the neonate will gradually gain control over sucking during the first year. Placing liquid in the mouth will induce the swallowing reflex.
In the first few weeks of life, it takes all the baby's concentration just to control these various uncoordinated.
All right, I'm going to pause it right there. So reflexes, when you talk about child development, are reflexes an example of memory? Because what you see here is like the rooting reflex. You touch the cheek and then something happens and the baby orients towards it, right? Or what they call the patella reflex, where you take the foot and you stroke it like that and the toes curl in one direction, right? That all babies do that whenever stimulus is introduced there. Now, here's the thing. This is not an example of memory. And the reason why is because this is not a learned behavior. Reflexes are innate. That means that whenever we are born, almost all of us come with these particular behaviors. We come with these different reflexes that we don't need to learn. They're critical for our survival. They help a lot with survival. But they are not something that we have to internalize, that we have to store and recall for later. So that's what makes reflexes not a memory. We got another example here. This one is kind of a fun one. I might get dinged for a copyright on this one, but I wanted to talk a little bit about music for a moment. So if this goes blank for a few seconds, that's because I got a copyright notice. Let's look at an advertisement now.
Build a website you
Told you.
love with Wix. For your words,
All right, so when we talk about music, like if somebody is playing an instrument, like we can see with this band right here, whenever they are playing instruments, or is that an example of memory? I think most people would say, yes, it is, right? At the very least, she has to remember lyrics. She has to remember the words that she is going to be singing, right? And that is clearly memory. We can also see that playing an instrument, they don't have sheet music in front of them, right? So they need to be able to remember what notes to play, what notes are coming up, and how to play those notes. So they need to remember how to play the instrument, not just the song. All right, let's listen to a little bit of this. All right, so that I would say this is an example of memory, because these individuals are recalling not just how to play an instrument, what their hands need to do. So there's like a motor kind of part of this, of playing drums, of playing a guitar, playing a keyboard, that what we call a muscle memory is involved in that as well. But the question then, I feel like, is this conscious recall or is this not conscious recall? To go back to that early question about explicit versus implicit memory, we'll be kind of looking at the role music plays in memory in just a little bit. The reason why I chose this band right here, Speedy Ortiz, is that they are considered a Western mass band, because I think some of them went to Amherst, I believe. I don't know. Speedy Ortiz rules. They're good. They're part of the grunge rock kind of revival from like the 2010s, I would say. They're still making music. They're good. All right. Here is a non-human example.
build a website you love.
So, man, YouTube really is targeting me to make a website, huh? All right. So this ape, Kanzi, who has sadly passed away.
Our way to make a fire. We're interested in the origins of human culture and the origins of human mind. Not only do humans diverge because of language, but humans clearly diverge because of their ability to make a fire. And he really enjoys it. He's figured out how to use lighters and matches, a lighter properly. Put it on the fire. Yeah, put it down. I'll get the food in it. Hansi understands about traveling to different places, and he understands about what we're cooking in the fire.
All right, so just to pause it for a second. So, obviously, Kanzi, the bonobo, doesn't know Dr. Ramba. Her name, she's passed away as well. This was Sue Savage Ramba from, I believe, Georgia State University. But Kanzi doesn't know language per se, but you can see like he seems to know how to build a fire, or at least how to light some kindling, right? Now, is that an example of memory? Would that count as memory?
That's a perfect marshmallow stick. That's one of the best I've seen. It's not done. There, you got it burning. Can you put the fire out before we go? Whoops, you didn't take the top off. You forgot to take the top off. Save some for the fire.
All right, so would that count? Would those examples count? Being able to make s'mores, knowing how to put out a fire, would those count as memory? I think we would say yes, but then so far when we've talked about memory, a lot of it is like being able to verbally confirm that we remember something. In this one, we have to infer based on the animal's behavior whether or not they remember something. So studying memory for non-humans is a little bit more difficult because we can't just ask them, hey, do you remember how to make s'mores? We have to find ways for them to show us what they have remembered. All right. So as we we just went through a bunch of different examples of what is and maybe what isn't memory. And so I want you to think again to yourself about whatever definition came to mind for you when you're talking about memory. Has that definition changed based on what we just saw? You don't have to come up with one, perfect, but it's something that I want you to be thinking about, not just this week, but for the rest of the semester. Next week, we're going to be looking at how memory changes over time. So I wanted to show this to kind of prime us to be thinking about this kind of information, about how, memory, we might be able to remember something, but whatever it is doesn't stay the same over time. And as we can see here with this particular graph, where savings for the memory that is being recalled drops very quickly, almost immediately. Within an hour, we have already erased half of what we have forgotten, pretty much. And then it slowly goes downhill from there. So even if we're talking about memories, we have to be careful because we know that memories are going to change over time. They generally get a little bit weaker and a little bit less distinct. They're more prone to error as time goes on too, and that is something that we're going to be talking about next week. So where I kind of want to end up here, how I want to finish talking about our introduction to memory, is to talk about how memory research is done. Because we can agree that memories exist, right? Like we just looked at a bunch of different examples. And even if we don't have the same definition, we probably have some agreement about those behaviors that we saw that would be classified as memories. But how do you know that I have a specific memory? If you were to ask me, hey, how long have you been teaching at Westfield? And I said, 8 years. That seems like I remembered that, right? But how do you know that I'm telling the truth? Does that mean that you now need to look to see if that statement is accurate? Yes, unfortunately you do, right? Because otherwise, I could just make up a number, and that would not be an example of memory. So if you want to know if I have a memory, you need to be able to fact check me, you need to be able to detect the accuracy of that, which is why usually a lot of this stuff is laboratory controlled, because that way we know exactly what people have seen, what they have heard, because we presented it to them. Whereas if we just ask somebody, we brought them into the laboratory and we said, hey, what'd you have for breakfast 2 weeks ago? They might be right, they might be wrong, I don't know. We weren't there to actually verify that information. So when we talk about whether or not someone has memory, a lot of it has to be very careful of what kind of stimulus you're talking about. But it also is difficult because we can't rely so much on just verbal confirmation, right? Because again, I could be lying or I could be guessing, and so sometimes you need to, like for example with a Rubik's Cube, that's an example of someone demonstrating their memory for something. If you ask me to recite a poem, for example, that would be an example of ensuring that I have a memory for something. But you can see how there's so much more to memory than just Rubik's Cubes and poetry, right? So sometimes we have to be creative, as you're going to see this semester as we look at some of the research out there. There's a lot of different ways that we can measure memory. We're going to look at some of those in just a moment. I want to mention a little bit about something that's called the black box problem. If you've taken cognitive psychology, you may remember the black box problem because it's something that we talked about at the very beginning of that semester. The black box problem is essentially that our head is a black box. This is supposed to be a head, but I'm going to pretend it's a brain now. So let's see. That's supposed. Oh no, that's so. This is. Oh boy, this is not a pretty person. I don't know what is going on there. Let me give them a little bit of a mustache. Look at that. I need to fix their chin. I don't know what's going on here. Anyways, but their brain in here, I can't be sure exactly what is in that brain, right? Because I can't directly see that brain. And that's what we call the black box problem, where we know that there's something going on in this organ, but we don't know exactly what it is, so it might be foolish of us to make concrete conclusions about what's going on there if we can't directly observe it ourselves. That's what the black box problem is. today we have a few different ways of kind of getting around the black box problem. Sometimes that might be that we're using really cool technology to look at the brain, so we're using fMRI or EEG or positron emission tomography or single cell electrode recording to see exactly what kind of activation we have going on in the brain, so we can use that. But even then, we have to be a little bit careful, because then we have to make sure that the areas that we are finding to be active are active because of that memory and not just because of random activation from something irrelevant. So this is all to say, be very skeptical, be very, I'm a very skeptical person. Even though I love memory research, I'm always very hesitant to be like, how do we know for sure that that is what that person was remembering? Are there controls? Are there other explanations for that kind of thing? So when we talk about memory testing, we're talking about the black box problem, about how can we know for sure what's going on in someone's mind. The way that we typically do that is from simply asking a question and receiving an answer. And I know that sounds extremely basic, but bear with me for just a moment, because the questions are going to change, and depending on what the question is, that can change what kind of answer you get to. So here is what I mean by that. So if I am talking, and I'm going to give you examples of each of these, and we're going to be looking at these again all semester. So these are, I would say, important ones to remember for now. We have recall, recognition, implicit tests, source judgments, and meta-memory judgments. So you don't need to know all these right now by heart. You don't need to tattoo them to your forearm. But these are things that we are going to be seeing throughout the semester, so it's nice to bookmark them now. So let's take a look at what we mean by just asking questions and answers. So if I want to know if somebody has a memory for a birthday, I might just ask them, hey, what is her birthday? And then they recall July 10th, 1998. If they are doing that, and that is indeed the correct answer, that is an example of somebody demonstrating recall for a memory. In other words, they were able to retrieve that memory by the date. But that's not how all memories work. And in fact, if I were to ask you, like, when is your mom or dad's birthday or whatever, you may not know off the top of your head. But if I said, like, is it April 1st? 1988 or whatever, and you said, no, it's not that. Well, what's going on there? Because you were not able to retrieve it. You weren't able to tell me what the birthday was, but you were able to tell me what it wasn't. You were able to say, it's not that, though. I don't recognize that. And so recognition would be another example of this. So if I asked, is her birthday July 1st, 1998, and you said no, that is an example of recognition, because essentially you were able to compare this birthday to your memory for what that birthday is and say, no, that's not it. That is not the stimulus I remember. That's not the stimulus I stored. So that's a slightly different example of memory. Now, those two things, recall and recognition, they may seem like the same thing. They are actually different areas of the brain. That is why I wanted to bring this up, because by changing the types of questions that we are asking, we are changing what areas of the brain are activated and helping us retrieve those memories. Here's another example: implicit methods. If I were to ask you, hey, can you show me how to tie your shoes? And then you demonstrated that, that would be an example of an implicit test. So in this case, it didn't require you to tell me anything. So when we talk about implicit memory, a lot of it is very indirect. If I want to know if you know how to tie your shoes, I'm going to ask you to do it. And I'm using this example specifically because, as you'll see, it's kind of weird. If I were to ask you to write down how to tie your shoes, it's actually really tough. Which lace goes on top? Does one lace go under the other? like how many loops you need to make. It's really kind of weird. And usually when I ask students to write this out in the classroom, I can see them like looking at their shoes or even like mimicking it out in air. So this is interesting because this means that this specific kind of memory lends itself to that muscle memory, to that kind of the behavior of it. But it's not really good for these other forms of like being able to recall or to recognize something. All right. Then the other two ways of questioning, we have source judgments and we have meta-memory judgment. So source judgment would be like if I was asking about birthdays again, and I asked you, how did you know it was her birthday? And you said, well, I saw a notification of it on social media. What makes this a slightly different question is now I'm asking you for your memory's origin. So a source judgment is your ability to remember where that memory came from. As we're going to see with some memories, we like here's one. Do you remember? I'm trying to think of like a big cultural event. Do you remember where you were during last election, when you got the news of last election, right? So that's something that we might all share. So we might all remember kind of what that night, where we were, right? But if I asked you, where were you when you learned long division? You can probably deduce it. You can probably work your way back and be like, I guess I was probably 4th grade, so I was Mr. Pope. Or something like that, right? But you probably don't remember exactly when and where you were. The room, what the room was like whenever you learned that. And that's because some memories that we have, memories that are autobiographical, those we typically do remember where those memories were formed. But for memories that are semantic, that have to deal with knowledge and facts and trivia, those typically we don't remember where we were when we learned those things. So like if I were to ask you about any vocabulary word, where were you when you learned what the word mitochondria was, right? And then finally we have meta memory. So meta memory would be like obviously you're probably familiar with the prefix meta, which usually means above. So we mean like memory above memory. So memory of memory. So if I were to ask you, hey, are you forgetting somebody's birthday today? And you're like, I don't think so. That's an example of you trying to rack your own memory and assess how accurate it is. We're going to be looking at this semester as what's called judgments of learning. So like how well somebody feels like they learned something before they take an exam on it. That's an example of meta memory. So sometimes you might be like, oh, I'm going to ace this exam. I feel like I remember this chapter really, really well. And then when you get there on the exam, you don't. You realize there's a lot you don't remember. That's an example of having a bad meta memory, that your memory for memory is bad or could be improved. But you may be also like, oh, I'm going to bomb this exam because I know I didn't study or that I didn't study well. And if you were right and you did bomb the exam, then congratulations, you have good meta memory. You have a pretty self-aware, accurate understanding of your own memory. A couple of key areas that we're going to be exploring this semester. We're going to be talking about the amygdala a little bit because the amygdala is going to be used when we talk about emotion and we talk about trauma and things like that. The amygdala is going to be a key player here. What else? The hypothalamus is used a lot for sensory information, so that might come up as we talk about visual short-term memory and things like that. And we're going to be spending a lot of time talking about the hippocampus. So the hippocampus, as you can see right here, it's called hippocampus because, if I remember correctly, this is something like Latin for seahorse or river horse or something like that. No, it is seahorse, because hippopotamus is Latin for like river horse, because hippopotamuses live in African rivers. So this gland, or this part of your brain, this organ, is going to be used for a lot of the storage functions of memory. So whenever we are soaking in new information, this organ right here is going to be what helps distribute it to other areas of the brain. So it is a crucial area. We're going to be spending a lot of time talking about it, and you can kind of see where it is. It's kind of on the inside of the brain. So this is, the side of the brain, and you can see that they kind of cut a slice using radio imaging or magnetic resonance imaging. But you can see here that this is where it is. So it's kind of inside what they call in the temporal medial lobe. All right, and that is pretty much it. Next week, we're going to be talking about the forgetting curve, so we're going to be diving into research. What you have for readings for this unit is just going to be a recent article asking about what the definition of memory is, what it shouldn't and should not include. Kind of an interesting, it doesn't, it gives some answers, but I think it allows you to kind of think for yourself, which I like about it. And then we have a classic article that is one of the first for modern memory research, which was the George Miller article. It's kind of long, but I have an introduction to it that you can find on Plato that kind of walks through why it's important and what I hope you get out of it. So thank you so much for tuning in, and I will check back in with you next week as we talk about the forgetting curve. See you later.